So in this video we are going to see about a special case of DFA called Mealey machines. So the DFA that we have seen so far has the set of states, set of alphabets, the delta transition function, the initial state and the set of final states. Right. So this DFA, the input to a DFA, so when we have a automaton, the input to a DFA was a string that is composed of symbols in the input alphabet, and the output was a yes or no decision, which meant the string was accepted or rejected by the machine. Right. So it's how do we find if it is accepted or rejected by the machine? After all the symbols in the input string is traversed, if the machine is one of the final states, if it is one of the final states in the set F, then we consider that the string is accepted. If the machine is not in the final state, then we consider that the string is rejected. So this is acceptance and this is rejection of a string. Now there is another class of finite state automaton machines which give us an output instead of this yes or no decision. So for a given input string, if the DFA emits an output symbol, so similar to our input symbol, if it emits an output symbol, it is a DFA with output. Okay, so this class is a DFA with output, and one such machine is the Mealey machine. So there are two machines in DFA with output. It is a Mealey machine and Moore machine. Two machines are there. So these are the machines which take an input string and it gives a output symbol. It emits an single output symbol or a group of symbols. So these two machines are DFA with output. So how does the tuple, so we have a set of states, input alphabets, delta function, okay, and we had a Q0 which is an initial state, and here we don't have final states. We are not going to accept or reject by final state. We are going to emit an output symbol. So we have two more things, a set of output alphabets. This is a set of input alphabets and this is a set of output alphabet and the output function. So this is a transition function. This is the output symbol function, a small o. So this is the tuple that represents a Mealey machine. So we know the transition function delta. How do we write it? For the given current state and the current input symbol, what is the next possible state? For example, if I am in the state Q0, Q0 sees a symbol 0 and transits to the state Q1. So we write it as delta Q0 sees a symbol 0 and moves to the state Q1. So this was given by a transition function because it represents a transition from one state to the another. So corresponding to the current state and the current input symbol. So similarly, our output function takes the current state and the current input symbol and gives the output symbol that has to be emitted. So the same diagram, how do we modify is Q0 on seeing a 0 moves to Q1 and emits the output symbol A. So this side of this the input symbol and this side it is the output symbol emitted for this particular move. Okay, so there are two functions, transition function and the output symbol function. Okay, and a set of output symbols, say for example, if my alphabet is 1, 0, which is a binary alphabet, input alphabet, my output alphabet could be other symbols, A or B. So it is a set of output symbols that we could emit. Okay, so this is the tuple for a Mealey machine. So in a Mealey machine, depending upon the current state and the current input symbol, the output symbol is decided, and it has one additional set called O, which is a set of all possible output symbols. Now let us see an example of Mealey machine. So for example, we have constructed enough DFA to find for the substring problem. So we will check if the given input string has a substring 101. Okay, so construct a Mealey machine to check if the given to emit the symbol A if the input string has a substring 101, and if the input string does not have an 101, emit the symbol B. So this is a problem. So your DFA is going to check the input string. If the input string has a substring 101, it's going to emit A. If it doesn't have the substring, it is going to emit a B. Now how do we draw the DFA for this? So the DFA, first we will draw for the simplest possible string 101. So 1, 0 and a 1. So we make Q3 as a final state and we complete the DFA when it's a normal DFA with the acceptance or rejection decision making. Now we are going to emit an output symbol. So 1 is an input symbol and I emit a B because still I have not seen, when I am Q1 I have still not seen a complete 101 substring. While it is in Q1 to Q2 also I am going to emit only B because still I have not seen the substring 101. But when I am taking this transition from Q2 to Q3, I have seen the substring 101. So I will start emitting A. So A is going to be my output symbol because I have successfully seen a 1, a 0 and a 1. Now when I am in Q3, after this I have seen the substring. So if it is a 1 also, I will emit A. If it is a 0 also, I am going to emit a A. Now let us go back and complete our machine. So Q0, when it sees a 0, it's going to self loop here with a B because it has not yet seen the substring. Q1, when it sees a 1, it's going to loop here. Now Q2, it has seen a Z1 and it has seen a 0, and now it is, if it sees a 1 again, it should go back to Q1 to continue checking the pattern, but still the output symbol will be B because it can change to A only when it has completely seen a 101. So now our Mealey machine is complete. So no final states here, but when an input string is given, it will emit an output symbol, whether A or B, depending upon the checking of the substrate. The second example of Mealey machine B. So let us say I am going to check if a string terminates with 11, I will emit a symbol A. The string terminates with 00, I will emit B. And if the string terminates other than these, any other pattern, I will emit a C. Okay, so this is the given description. We have to construct a Mealey machine for this particular scenario. String ends with, okay, it ends with 11, emit an output symbol, 00, emit B. Any other pattern of 1s or 0s, you emit a C. So our input alphabet has 0 and 1, and our output alphabet has A, B and C. So let us start drawing machine. So Q0 on emitting, this is 0 path and this is the 1 path. So I will emit C because I have still not seen 2 continuous zeros. So when I see 2 continuous zeros, I am okay to emit a D over here, okay, in Q2. Q1 to Q2 transition, if I see because I have seen 2 consecutive zeros, I am okay to emit a symbol B. And the same way here I will go for Q3, wherein here I will emit a C, and if I get 2 consecutive, this would be A, Q4. Now I have to complete my DFA. Now if I have reached a 0, 0, how many ever zeros I see, I am going to emit the same output symbol for 0, 0 termination, and how many ever ones I see, I will emit A because it is a 1, 1 termination. Alright. Now what happens when Q2 sees a 1? When Q2 sees a 1, it goes to with C. It sees a 1. So after that it will check for this. And similarly, when Q4, when it sees a 0, 1, 0 it has seen, okay. So it has to go to Q1 to check for the other 0. termination. So this is Q2 and Q4 are completed. Now we have to complete Q1 and Q3. Q1 sees a 0. What happens if Q1 sees a 1? Again, Q1 sees a 1, comes here with C. Q3 sees a 0, it has to go here and start checking for the remaining matching. So now we have completed and we are emitting output symbols according to the termination. We are not having any final state and we are not deciding if it is accepted or rejected. For the given input string, we are emitting an output. Now we can take an input string so we can take an input string and we can check. So it is like Q0 on seeing a 1 goes to Q3, it emits a C. Q3 on seeing a 0 goes to Q1, emits a C. Q1 on seeing a 1 again goes to Q3, emitting a C. Q3 on seeing a 1 again goes to Q4, emitting a A. So our final will be A, which is for 1-1 termination.